the last few years, actually I've been kind of slowly getting obsessed with this particular topic of smart cities. It was just accidental that I kind of started into this, but I think it's kind of turning out to be a very interesting, I think a rich space for a lot of interesting research problems, which is what we are interested in, but also an opportunity to really shape how these things will get implemented in India right now. So, so I'll just kind of try to present a kind of coherent story on what we could do as technologists for enabling really kind of futuristic smart city solutions in India. So, and really one of the main things which we have been kind of trying to make a case for is like an open stack which will really allow for a rich set of applications to develop and emerge in the future. So, to motivate this, what I'll do is I'll kind of go a little bit in detail into this recent RFP which has been put out by the city of Agra, which I'm sure Bipin out here would be able to kind of tell you in much greater detail of many of the other aspects of this RFP. And we'll just focus on the technology related aspects of this particular RFP. And I presume that this is a kind of a prototypical RFP for a smart city, which is kind of similar to a lot of the what the other cities are doing or want to be done. And if you see out here, one of the key elements out here is this integrated control and command center. So clearly they want like a visibility as to the overall operations of the city. And there are a number of components which kind of plug into this command and control center. Transportation, intelligent traffic management system, solid waste management, surveillance, interactions with the citizens of the city, being able to communicate through digital signages and so on. So these are all the various kind of components which they would like to kind of have executed in the RFP which they have given out. So what we thought was, let us go into this RFP a little bit more detail to understand from a technology perspective what are the kind of key elements which will need to be supported. So, so the RFP also kind of says that you need to have a layered approach, and this is kind of also common sense. In some sense, especially with all the sensors being deployed like cameras, etc., they advocate having these multiple layers out here: sensor layer, a communication layer, data layer, and application layer. And what I would like to focus on as we go forward in this talk is essentially this layer, the data layer, which I believe is like the core fundamental layer which we really need to make sure it's designed and constructed well, because it will really enable all kinds of interesting things to happen in the top once if that is done well. So, so if you look at this the adaptive traffic management system, what they would really like to do is to be able to kind of manage the traffic in a reactive, smart way. For example, they want to be able to control the traffic signals optimally so that it can change as required based on the duration, on the time of the day and the traffic conditions. I guess this is a big deal in India, VIP vehicles. So they want to be able to, automatically create these corridors for VIP vehicles as well as emergency and police vehicles. They would like to actually have incident messaging being done in real time. And also they are a little forward looking in the sense that they are saying, let us collect this data of all the traffic conditions, make it available so that it can be used for further analysis and improvement of the road networks. So if you look at the implication on the data layer, this real timeness is kind of important, which emerges because you want to quickly be able to connect to various things. Also, you want to be able to, of course, it's not immediately apparent from here, but if you look at the RFP in detail, it's also apparent that you want to be able to ingest data from a diversity of sources, cameras, crowd source, police database systems, etc. Similarly, you want to make this data available to a diversity of applications, and it's not just this adaptive traffic management system application, but maybe other applications. They have these, then yeah.
So, I don't know about Agra, but most Indian cities, the bottleneck is the infrastructure, right? The roads are not wide enough to support any of this stuff. So, how will any of this make a difference? Optical signaling on a road, there's no space. How are you going to actually improve it?
That is a very good point, and I don't have an answer to that. I mean, if you don't have enough capacity of the road, I mean, there's not much you can do, in terms of that. But hopefully, you can at least do some demand response type thing. You can stagger how people, try to kind of even out the capacity by, creating incentive schemes and so on.
Has anyone studied whether there is feasibility of any of this making a difference? Because the government is spending money on something that is going to give you zero results.
So that is one view, is that why do all this when we can't even make a proper footpath? You go out there, we are not even able to walk properly and we want to fly, But maybe we kind of bypass this, like what we did, with wireless. We have directly gone to smartphone, we are bypassing the intermediate layers. So the other thing is that I think one of the things also which is embedded in the RFP, it turns out, is that this just making the information available hopefully will allow citizens to kind of say, look, what the heck are you doing? Are you doing a job? Why haven't you fixed this and so on? So that also, hopefully, there will be some positive which comes out of just making the data available. Right. Yes, yeah. So Agra, I don't think has it said anything about public. Bicycles, okay. So, you have to also get the appropriate insurance. Yeah. There are a lot of interesting, okay, so for example, I'll point out something funny out here. So intelligent traffic and CC surveillance. So traffic comes again in two different places, adaptive traffic as well as part of this, but I'm just kind of reporting what they have said out there. Here they really want to have the system support the police. So this is from the point of view of the police's perspective. They want to be able to, traffic police, be able to give fines, do traffic management, monitor suspicious people, vital places, video analytics, right? So they want to be able to detect no helmet, whether someone is smoking in the car. This is funny, wrong lane driving detection. So they want that, I don't know why. They would like to actually also detect if people have long hair or short hair. It's there in the RFP, okay. So this is kind of interesting. They would like to have video coming from ad hoc video sources. You just set up a video network and then data should come from there, or wearable, like police is wearing a video camera, data should be coming from there and so on. And then of course they want this to on top of the secure communications. So what this implies is for the data layer, you need to support end-to-end security and also diversity of video sources, mobile, wearable, ad hoc type sources. And you need to really support a diversity of analytics, which might not be doable right now. See, the point is some of this, long hair, short hair, it might take time to evolve that. But in the future, you'll have more requirements for analytics. And then of course, strong authorization and authentication. Solid waste management, they have, and this is probably true for most of the cities, they don't know what is going on, are people actually collecting the waste they're supposed to, are they disposing of properly and so on. So they just need more visibility by putting sensors to track vehicles, monitor the waste collection sites, manage the routes of these trucks, etc. Look at the handover from one small truck to the bigger truck, what is going on, things like that, and really increase automation. Again out here, diversity, data ingestion from a diversity of sources followed by video analytics. They also want video analytics. They want to see what is happening in the monitoring, the waste disposal sites. Are things being done properly or not? And they would like all of this to be reported, summary to be reported to the integrated command and control center. GIS is a big deal for this, I guess most of the smart city RFPs, where they would like to use this for better revenue management and planning and urban development. and maintenance of public places and so on, and they would like this to get integrated with other smart solutions, lighting, surveillance. So GIS is an important requirement for the data layer, being able to provide GIS data and space data. I will come to this, what I mean by this little later in the talk, so that you can do a correlation analysis of data from all these different sensors in the context of GIS data. Air quality, noise, light, and being able to report that through messaging displays is something they would like, and they would also want these to be tamper proof. So this is where it's kind of interesting. Some of these requirements are coming up in the specific components, but they are general. They kind of cut across the entire implementation of smart cities. So secure onboarding of devices is important, so that you can trust the device which is sending the data and detect if the trust is broken. You would like to kind of know how healthy these devices are, and then really, again, coming back to this, exchanging data between sensors and other applications.
Can you say a bit more about the noise pollution?
I guess they want to kind of measure the amount of noise decibel levels in these places. Just monitor that, I guess. And you could, I guess, if you had these microphones, you could also do some analytics with that in conjunction with the video, though they are not asking for it, but you could do some interesting things with that, I guess.
Are there any laws or something that if you measure something, you find noise pollution, you can do something about it?
Yeah, I don't know. I'm not aware of. I'm sure there are certain probably laws. I don't know. I mean, yeah, I don't know actually. See, it's like the air quality, right? I mean, there are certain safe air quality levels to be maintained, but we are kind of not really maintaining that. So probably the same happens with this noise. Huh? Taj? Oh, okay, I see. Yeah. So Taj Mahal. Okay, so that is driving some of these requirements. Okay. I guess once you start having data, see, that is the thing, is that maybe you can kind of use that to drive some actions, policy actions after that, around that. So, for example, this kind of data would also be useful to correlate with the health implications of the people living in those areas, right? So we don't have data, but once we start having this kind of data, those kind of studies can also be done, and then we could inform the city could kind of do the appropriate things in terms of, yeah. For noise? Noise, I don't know, but I do know that maybe the same people, because air quality related studies, some of the doctors in some of these hospitals are interested and kind of doing that kind of study along with some scientists in IISc. So I guess noise is kind of related, so probably they would also be interested in that, yeah. So St. John's is something which is...
So Bharadwaj, in New York City, to Manik's point, there is city code about what is allowable noise.
Okay.
And anything which is 10 dB above a certain ambient level, which is informally stated as 55 dB is prosecutable. But then they have very specific prosecutions for different types of complaints. And it is in fact treated like a health hazard.
Health hazard.
And it is known to also affect educational outcomes. So kids who are studying near, say, railway lines, their ability to succeed with. So there's many agencies which are interested in managing noise.
The air quality, for example, the study which the IISc scientist Professor Satish did along with some of his colleagues from the hospital was to look at the asthma levels of children in a school, before and after some change in the traffic, routing. And there was a noticeable change in the asthma levels when, of course, they changed some, traffic, so the paths for some of these heavy vehicles. And over a 6-month period, the asthma levels actually went up. And then it came down when, the old routing was established. So clearly, there is a major connection out there with the health and even the educational outcomes. Too much noise might also prevent children from focusing and so on. So they want this latency of 15 milliseconds round trip, which I I don't know, I think it might be kind of aggressive with certain jitter specs and loss specs and so on for the communication network, and authentication of devices through the certificates and being able to look at the health of all these things. So I think the message here is that real timeness is important. Whether one can meet these specs or not is a different issue, but I think that makes sense. If there is an ambulance coming in, you want to kind of notify it and change the signals and so on. Maybe.
I have to ask, where did all this come from? Who actually produced this?
I think it's Price Waterhouse and Asian Development (ADB).
Price Waterhouse,
They
specifications,
yeah,
change later.
exactly, yeah. So it could also be that certain big corporates also help come up with these specs so that their equipments will meet these standards. I don't know how this works, but
I think this just covers one tiny part of this whole thing. There is no quality of service, there's no spec on how good your sensors have to be, right, or how accurate the prediction.
Absolutely, absolutely. In fact, that is the point I kind of want to make, is that if you look at these RFPs, this, in some sense, this is the level at which the specs are written, and it's already like 300-page document, just this technical stuff, and then from there to derive even more detailed specs, that's where what I want to make a case is that we really need to get down to those details, of being able to properly get to the next level of technical specifications of each of these layers.
Wouldn't that specification drive this? I mean, at the end, this is not useful to people, right? But all what you get out of it, that's where you
Yeah.
go back to these.
Yeah, that's why I kind of put this up, just so that it kind of comes out. This is the kind of spec which is there right now in the RFPs. This is what they're asking for. Yeah.
So I'm sorry, I can't see this. Like,
Sorry. Yeah.
what exactly is the 15-millisecond latency for?
See, they have just spec'd that it needs to be end-to-end latency, round-trip latency is 15 millisecond. Now, I presume it is probably they had these applications like this signaling, traffic light control, creating a green corridor when a VIP vehicle comes or emergency vehicle comes. So maybe that is driving this particular spec. And yeah.
What is this 15 milliseconds to do exactly what?
15 millisecond from the time the sensor says, look, I am an emergency vehicle, I am here, to going and changing probably the traffic light to set the green corridor up in that local space. I'm kind of speculating that is what is driving one possible example use case for this kind of a spec. So from the sensor, it goes through the communication network, it has to go through the app. So here they are not even mentioning anything about the app, because there is a complete application stack through which it goes and comes back. Everything has to be within 15 milliseconds. And the jitter of 2% of 7.5 millisecond, that is, jitter is 2% of the one-way latency, probably for video or something. I don't know where that is coming from and what is the motivation for that. Yeah, so this is the, yeah. So the integrated command and control is like the key piece of the smart cities, right? And really they have an aspiration to break the silos between departments. They want a single window visibility of all that is going on in the city, and they want to have this integrated operations platform, which is like the core of that, which will expose data through APIs, support distributed deployment of workflows, stream analytics, correlate, handle multiple data stream, developer support, vendor agnostic, software development kits, APIs, secure APIs, and they want to have analytics for loitering detection, abandoned objects, etc., etc. I'm kind of bringing these things up because this is kind of how the RFPs are also written. In some sense, these are the consultants who come in and write these RFPs. There are some elements which are captured, which are what is the cities want. Plus, there are certain other additional things which are put in. Yeah. See, this is what they have written in one of those places. So what we want to actually, we seize on this and we are saying, let's make this. Let's try to get this thing, achieve this as an open stack, open API framework. And now this is the RFP which has been put it. And in the normal course of operations, what will happen is that there will be one master system integrator like Streetlight or L&T or someone who will pull together all the different vendors for surveillance, waste management, etc., etc. And probably each of the vendor will have their own complete stack from sensors all the way to the dashboarding. And then somehow they will integrate it into there will be a single command and control center where you'll have all these little snippets or videos running from each of these different applications. So it really is siloed in some sense. So that's probably what will happen. There is really nothing more specified in terms of further levels of specification in terms of standardizing the framework for exchanging data, so that you can really exchange data across different applications, devices, and even cities in some sense, right? You want to kind of go to that level. So also really there is no support for an economy based on data, because that is kind of the recurrent thing in any of these. That data is a recurrent thing, so you have to figure out how to make money off data. So there is really no support for that. So that is a little bit future thinking we need to do. There is no mention of privacy. So that is, we now know that is one of the most important things right now, but there is really no mention of privacy in these. So what we really need is kind of a platform which standardizes the APIs and the data models so that it helps application developers. So it should be targeted at application developers instead of just having end complete applications. And then it should really support AI type solutions which are emerging, and really unleash the innovation and entrepreneurship for new applications to develop.
Do you know any smart cities following coming up
These applications? Yeah, there are a lot of, I think already Pune has implemented something, and some of the cities have, which are a little bit early, have implemented that. So you can have vendors, for example, which will provide you solutions for surveillance. So there's someone called Videonetics who will provide you the complete with the cameras and VMS and all that. Parking, I guess there are a lot of players, startups and so on, and so on, lighting management. Pardon?
Calcutta has done surveillance on traffic signals, like if you're overspeeding, they automatically message you
Right.
that your car is overspeeding, or if you break the signal. So Calcutta surely has it. I'm not sure.
Videonetics, yeah.
Is there any law in India that protects privacy? Do I have right to it?
I think there is something which is there in this the data empowerment and privacy DEPA, DEPA, I think, right? That is something which has been yeah. So I think MeitY has adopted it. So I think those guidelines are supposed to be. That's what someone who was involved with that told me, that that will be legally binding. So
This does not. It's seemingly there's nothing. It's not following any of it.
no, not right. Yeah, because this privacy thing is like a very recent thing which is kind of brought to our attention, right? In some sense.
Is there a plan to build privacy into this stack? Or?
I'll just come to that next year. So now what we are saying is that let us focus on the data layer, right? And we really need a well-defined data exchange layer. And it needs to be an open platform with open APIs and data models, so that instead of this siloed, it gets replaced by this, what I'm showing is a hourglass model. At the neck of the hourglass is the key. That is the city. It's a little verbose city data exchange and edge analytics stack. And I'll tell you why edge analytics is important shortly. So this data exchange stack, what it does is it's an intermediary between the producers of data, which is all the sensors, and the consumers of data, all the applications. The sensors could be hardware sensors, but it could also be software sensors. Other applications could do further refinement of data and produce alerts and messages and so on. And really this kind of an open stack will enable very complex applications in the future, emergency response, which ties together information from multiple diverse sources and connect with multiple different ways of connecting with citizens, crowd monitoring, accident detection, as well as prediction and preventing accidents. So that is kind of what we really need going forward. And to do a lot of these things, you need to integrate analytics across video and other sources. If you see, currently video is a complete separate beast by itself. Video is separate, everything else is separate. So we really need to kind of integrate, as an application developer, you need to be able to consume a video stream as well as stream coming from other sensors nearby. And really this architecture is, this is something inspired by Aadhaar. This is what they do for Aadhaar, right? There's a core kernel you identify, which enables a whole set of ecosystems to be built around it. And if we do it right, we can have portability across vendors for devices, as well as portability across cities. Application developed in Bangalore should work in Surat, etc., etc. So I think that is what we should be aiming for as a country, not have all these cities independently just doing their own little thing. And then, at least this, let's see if we can do it correctly. The smart city solutions. That is our hope. Yeah.
Is there a sense of the magnitude of the data and what will be done with it? So once the data has been sensed, is it going to be stored and archived somewhere, or will it just be lost after whatever happens?
That is a good question. So nothing explicit has been mentioned in the RFP, at least I couldn't notice, but certain numbers are mentioned. Like for example, for I think for surveillance related application, we know that people want to store it for at least 30 days or something, I believe, and the video data. The other sensor data is really not much, I guess, compared to video. Video is really the beast in some sense. And they are saying that you have the archive data to do further analysis and help and so on, but it's not really been quantified. I think that is the next level where one has to be able to say, okay, you need this much amount of storage to store these kinds of data. So for video it is there because certain requirements require you to store so many days worth of data. But
and is there anything that says that the raw data has to be stored, or there could be some kind of filter running on the data which flags interesting events or important things, and then only those are archived rather than the raw data?
see, I think for video from a forensic perspective, they definitely want the raw data. In fact, you should not be touching the raw data. It should be as it is, right? But there could be a lot of other cameras which are not really part of the surveillance system. You just put them. For those, I guess it's up to how you implement those, right? I mean, do you really care for this raw data coming in where nothing is happening? Like a waste monitoring site, you have a camera. You just want to know if someone is actually, if people have showed up to work or not, maybe, right? I mean, maybe that's the alert you want. So the raw data might not be that useful there. So I think that is also kind of open in some sense.
And it is feasible to store the raw video data to actually even just forget store, even stream it over the net?
So that is okay. So that is really why the edge analytics comes in. In fact, maybe I'll just kind of say why we need the edge analytics is essentially for what you pointed out. The amount of video data is just too much to stream to the cloud. It has to be locally stored, locally consumed.
Local as in local to your
Local is what? So local could be a ward, maybe a locality. Again, it depends on the kind of investment the city is able to put in. I feel that it should be local at the level of a ward or a locality or a campus or some such thing. And then that's kind of what I'll kind of discuss in the next few slides, so that you don't really ship these huge amounts of data all over the place. It's just consumed there, and then that's why you need the edge analytics also running there. So only the alerts, etc. are sent. So this data exchange layer needs to have, what are the attributes for this, right? We need to have very strong security, handle heterogeneous data across video and other IoT data. This is the key functionality of supporting exchange of data between various applications and devices. Be a repository of data models, because just raw data by itself is not useful. What is the metadata about the data? And that is something that has to be insisted on, that every source of data comes with metadata information so that you know what it means, support low latency, have APIs and SDKs. And because of the need for local, just for video, if it was not video, probably edge analytics might not be that useful, but maybe other than for latency reasons. But definitely video requires, I think, fog/edge analytics. Now what was missing here, we would like to also add these three requirements, that there should be strong protection for privacy. So if someone is, you should know as a citizen which all cameras or what all video feeds you appear in, right? I mean, that would be nice to know. And then you need to have a marketplace to be able to buy and sell data, and of course support AI type applications. I'll kind of briefly mention what I mean by that.
I would not call that strong. I mean, once I've lost, it's not privacy anymore, right? That you're telling me I have right information, but not privacy.
Correct. Yeah, at least be able to know. See, because if you take that forward, right? Suppose the cameras are put, but maybe you lock the data in which you appear, or what you want, and that is unlocked only based on
Sorry, last year Supreme Court made privacy a fundamental right. Whatever that means. There is a data privacy law that's going to be tabled end of this month. There's a Sri Krishna Commission which has been charged with drafting India's data privacy and protection, and they have been at it for some time. Supposed to deliver it end of this month, which is supposed to take into account fact that GDPR on one end is extremely strict, and in the US there are no real control. We're supposed to be in the middle path, and that protection we'll talk about what you're. There is going to be the law. So that's the end of it.
With this right to information, there's these cases where in Seattle the system was abused by asking for so much information that the city authorities were sort of ground to a halt, just satisfying those requests. And then there's the issue I think Manik brought up, where if you have access to excessive data, you're bearing a cost on someone to deliver it to you. So, is there any thinking on how you will manage, access and sustainability of cost?
I think those are all opportunities for startups to offer services along those lines. That's what I think. So, for example, analytics as a service, right? Annotation as a service. All these are interesting opportunities to think of coming up with solutions for those. And that's where these kinds of data stacks, which are very open, will support those kinds of new kinds of services to come up. So this is the stack, basically what we are saying, and it's not very different from what any of these IoT type stacks look like, except of there are a few things out here. Of course, you have the brokers for streaming messages and alerts and so on, which is kind of an archive, being able to access these archived versions of these messages. Also support for real-time messaging, but the video and audio, the media brokers and databases are also part of this stack, so that you access this. And basically a directory of data resources out here, which is a catalog, which has all the meta information. I'll kind of give an example of how that might look like. Support for certain contexts, because if you want to really interpret the data coming in, you need to know what is the context so that you can do your inferences and so on. So that is kind of what I meant by AI support. And as specific example, I'll just talk about the spaces. Then, which is also very important, I guess, in the context of video and edge analytics, is that you need to be able to support running of analytics. I'm not, this is support to run analytics at the fog and the edge layer. And then a kind of a framework for authentication, authorization, provisioning, etc. As part of this. So this is basically the stack, and we want to kind of, and all this is kind of exposed as APIs, and each of them runs as services or microservices in some sense, from an implementation perspective. So if you look at from a deployment option, you have the stack at the center, and currently what will probably happen is that you already might have applications running. Waste management is an application someone has developed, etc. So with adapters, you kind of put data into the stack, and the command and control center will pull data off the stack in some sense, and also communicate through these. So this is kind of how probably the immediate future with legacy or ongoing applications, things will work out. But maybe going forward, you cannot decouple the data producing portion from the data consumption portion. Even the data producing portion is just done by a bunch of companies, and consuming is done by some other bunch of companies, and all of them work through the data exchange stack in some sense. So, So what you can see from the command and control center is not just the data, but also the health of the devices and health of all the things producing the data. That is essentially all the management systems, VMS, element management system, network management system. They also report the health of all these different different things to the command and control center out here. When we think in terms of, that is kind of the software perspective. When you look at the hardware perspective, what you will have is a collection of gateways or IoT gateways which are out there publicly deployed, possibly on street poles, because those are something which are all over the city, they have access to power. So you have these street poles where each street pole has this IoT gateway with a bunch of locally wired connected sensors and actuators, and perhaps also ingesting data from nearby sensors wirelessly. And all these street poles are connected through a WAN to the local micro data center. So this could be at the level of a campus or a ward or locality. And this micro data center actually has the WAN terminator, network switches, and then compute and storage servers as part of it. So this becomes the what is called the fog node. Some people call it the fog, some people, the different terminologies, but this is the micro data center sitting there, kind of serving a locality out here. And so we kind of expect this to be kind of the hardware realization of the smart city solutions. And if you do it that way, you can kind of do it in a modular fashion. Each locality gets lit up in some sense or IoTified, and then you have all these micro data centers which are then kind of managed or visible as in a unified way through your integrated command and control center. So this way you kind of slowly light up different portions of the city on a step-by-step basis. And the software itself, you would want to, of course, make it run in a distributed fashion. So what here I'm showing is that the core, the API gateways and the authentication, etc., is in some sense unified and centralized. But the stack itself, the brokers, etc., are run in a distributed fashion, each in a local micro data center. So that way, the whole thing is actually distributed out here. So there are a few concepts which we kind of want to kind of bring out here, which are kind of I think interesting, and maybe some of them are a little new in some sense. So one is of course the registry of data sources. Now this is something which OCF is also, and there are multiple approaches to or efforts to try to come up with a schema or a standard framework for capturing the metadata. So we are looking at, we looked at what OCF did and and we are proposing something along those lines, where any IoT source or any data source has a schema which has 4 pieces of information. There is some static information, there is some schema about the observation data which comes in, schema about the control data which goes to the device, and then schema for the configuration data. And as an example out here, one of the elements is the output of a lux sensor, which is of type number, which is measuring the LED output intensity, units of lux. And it has, what we are also saying is that there is an access modifier to kind of control the privacy setting out here. So you have private data, you have protected data, you have public data. Private data is only accessible to the owner of the data, whereas protected is data which is available to someone who is authorized, and public is open to available to everyone. Now this kind of schema, the idea is that any data source, when it gets registered in the system, also has to put in a schema which describes what is the, which kind of tells you about the format of the data coming in, and then the system can validate the pieces of actual data which come in against the schema. That is what is shown out here on the right side. So as an example, if you take a Streetlight, which so this is the kind of schema which this is a proposal schema which we have kind of experimenting with in our reference implementation, which gives you some meta information. This is the static portion. Where is the Streetlight located? Who owns it? How do you access the data from the Streetlight? Which is what is the subscription endpoint? What is the API endpoint for getting the archival data? And then the data from the Streetlight itself, what are the different pieces of data which come in, essentially when is, like this is the sampling instant, which is the temperature of the casing, the power consumption, the ambient lux, etc., and then some meta information describing each of those. So this is the control information, that is how do you go and change the brightness level, for example, of the Streetlight. So the actual data from the Streetlight will of course be these JSON type documents, keyword values which are adhering to that particular schema out there. So that was the first thing, is that every piece of data has to have this data model which is uploaded. The second is video itself, right? So now with video, what does it, we would like to also treat video as an IoT element. What does it really mean for video to be an IoT element? Well, we need to have some metadata about the video, and metadata on the semantic content of the video, not just the frame rate and resolution and so on, but what is inside there, some description, right? We had this lux sensor and the units are lux. Is there some other similar information we can put, maybe about the semantic content or some associated information? I'll give you a simple example. So for example, if I look out here, someone could do an analytics on this video and give out this metadata stream which is associated with the video stream, which tells me where are there any autos in this video sequence, how many diesel vehicles are there, etc. The thing is, these kinds of analytics then help the consumer to work off the analytics data and not worry about the raw data anymore or the encoded video stream. Now you are working on the derived information as you go forward, right? And this will really enable complex applications to be built where you build on this kind of analytics, and it will also allow analytics service providers who develop very specific analytics and offer them as analytics stream. So this formatting is a little messed up out here. So for example, a simple use case is, let us say you have a mobile video source like a drone, and the drone is giving out the encoded video stream, but you would like to know what is the geolocation as a time series, so that is the extra meta information, because if you had that, maybe geolocation, maybe the pose of the drone, you can do better, much more interesting inferences with the video stream. So it's just a simple schema to describe that, very similar to the schema of the Streetlight. Here I'm just looking at the data portion of the schema, which is telling me that this is the timestamp of the metadata. This is you need to be able to refer into the video stream. What portion of the video stream is this piece of metadata actually matching to? Start and end pointer of the video, and then what is actual data coming is just a latitude, longitude in this particular example, saying that this portion of the video frame, this is the geolocation. So you have now a stream of, that's what this picture kind of tells you. You have the video stream which is flowing out here, and you have this metadata of corresponding to the video stream which is flowing on the side out here. So for example, this piece of this metadata stream, each metadata packet actually is referring to some portion of the video and then contains some information about that video stream. So this is one thing. So have this metadata stream which is also in the catalog. So any consumer will know, okay, what is this derived information available, so you can build some new applications on top of it. And secondly, if you want to subscribe to the stream, the video stream itself, you need to have a way of, just like you would subscribe to a IoT data stream, you need to be able to subscribe to video streams. So you need to have streaming servers, be able to access archive streams, etc., and the corresponding metadata which comes in out here. So one of the things is that a lot of the video, especially for this surveillance camera, is of only local spatiotemporal relevance. No one else outside really cares about it. So I'm just kind of highlighting here kind of a problem, at least which we are thinking about, is how do you create this localized efficient video distribution system for the local region. So this I think is where you have load balancing, you have caching of these brokers, etc. done. For example, you are stuck in a traffic junction, or you are stuck in the road and you kind of want to know what is happening ahead, right? You're just curious. So with your city app, you are able to subscribe to a video camera which is just ahead, and you'll see, okay, this is why there is a problem there. You're just kind of curious to know. So this kind of a local consumption of video from a local source to be able to support these kinds of things. Also, be able to kind of adapt the QoS of the local network. For example, if I have some incidents happening in a local region, you probably want to allocate more bandwidth to the cameras around that region. Right? Maybe you want to track a crowd as it's going past, right? So adaptive QoS for those things. So these are some of the, I would say, interesting R&D problems. I'm not saying this will be part of the stack which we are doing, but these are some interesting problems which kind of are worth looking at as we go forward. So the thing with the video is that you want to kind of consume the video and analyze the video locally. Right now, of course, you do it at the fog layer because those are standard compute servers, but I guess with technologies which you guys have developed in MSR, you could also push that to the edges out here on the IoT gateways. Okay. Now the thing is that this collective of the micro data center and this IoT gateway in some sense forms a cloud. I kind of call it the street cloud. So you have to and street cloud has this heterogeneous compute resources, little computes in the IoT gateways and more compute in the compute servers. So so basically you kind of want to locally terminate the video both for privacy and bandwidth, and you want to run this analytics out here in this street cloud. And so how do you do that? You know, what is the programming model to allow you to kind of develop applications like this in a general way, and what kind of runtime is required to support that? And I'm kind of, you know, so this is something again I think is an interesting kind of systems problem to kind of look at as we go forward. As an example, we have been looking at this, you know, how you could take advantage and do this kind of distributed video analytics, right? So where you have a camera and you have some compute at the pole right next to the camera, and then you have more heavier duty compute out in the micro data center. So here what we have explored is how you can do this tracking locally and the object detection out in the micro data center. So this is some work we did last year, where you have multiple cameras, and then you have an object detector running in the micro data center, and the D frames are the frames on which you do the object detection in the data center, whereas the T frames are done locally next to the camera to do the tracking. So the detector of course runs is a much heavier duty detector running on one of these neural nets, and locally you do the tracking, etc. So there is some benefit to doing this. We reported last year, but I think more interesting question is how do you, when you write these, because you know it's always a moving target. The amount of compute you have every year is improving. Even in the edge node you can do more and more compute. So you can't like hard partition your thing saying that what you couldn't do today, maybe 2 years from now you can do easily in the edge compute. So how do we write these applications and break it so that these pieces are able to move around easily, and collectively they do the job you want to do? So that I think is also a very interesting problem. So there is this, the third concept which we kind of want to articulate out here is concept of space as an asset, right? The space regions, and this is something which actually Intel has been kind of brought to our attention out here, who are also part of our collaborators out here. So this particular region, this particular conference room is a space region which should be there in the database. Because if you have sensors out here, for example, a smoke detector, right, you should be able to pin it to this particular space region, which means this space region needs to have an entity, kind of a presence in your database with a specific ID so that you can tie to that. It can't just be the geolocation out here, because you can't, the geolocation will not work well inside. So that is a kind of a concept where you have spaces articulated as assets. And the thing is that, for example, these spaces, if you take, this is the map just outside around this vicinity where you have your Microsoft building, you have ITC Gardenia, etc., etc. So I have just marked out 3 space regions. So there is this SR1, which is this piece of road, SR2 is your Microsoft building, SR3 is this another building out here, and these regions have to be captured somehow. Of course, in the database you will have SR1 as a region which has a unique ID. It is described as a street segment owned by the city of Bangalore, administered by BBMP, etc. Similarly, you have associated information for every regions. But more importantly, you have a structure which connects these space regions together, saying that SR1 is adjacent to SR2, SR3, etc. and SR1 is part of this bigger space region called a road, Raja Ram Mohan Roy Road, and so on. Now, why is this kind of interesting? Because you know, you can kind of use this structure to build your application. For example, suppose there is an incident which happens in this SR1, which is a road segment just in front of you, right? Who are the people who need to be informed about that? Suppose I want to just build a general application, right, without customizing doing it for this particular. So then what you would do is you would take that, you look at the network, you know, this graph structure, and traverse that and figure out who are all the affected people who get notified about that accident. So and you know, this kind of this is the context. What I meant by saying supporting AI services is that you capture the context, and this context is most likely in the form of a graph. And it need not just be context of the space region, it could also be context which is related to the organizational structure, you know. So there are many things out here which are useful, which probably should be captured. So I think that the challenge here is to populate the database with such kind of information in a maybe automated way, perhaps a semi-automated way, so that you have a rich database which you can now start using to do more and more interesting automated AI type applications. So, but at the minimum, at least what we are saying is let us start with the space regions and make that available as a database. And this we should be able to automatically create analyzing the shape files and so on. So finally, the security, privacy, and manageability. And regarding privacy, I will just briefly mention that there is work which is going on in India Stack as part of privacy, supporting privacy, and they have something called a consent layer which they are proposing. So one can look at that and see how we can adopt it. But the idea is that there is a clear ownership of data, who owns data, and the data can only be used with the permission of the owner of the data. So that is basically what we want to be able to support out there. And also it will be good to be able to track if I share data with you, you don't share it with someone else without my knowledge, right? So we need to also have a mechanism for doing that. So I think those all can be done now with this modern encryption and public key PKI technologies. So what we have done is this particular, these are all kind of concepts at various levels of maturity. Some of it is actually work in progress, and we have actually been working on implementing some of these. Yes, go ahead.
Sorry, I didn't know you were about to transition. So I thought you were also going to say something about security. If it's an open system, what prevents me from inserting malware that can do whatever I want in the system? Like I could monitor an ATM or figure out where all the police cars are.
Yeah, so so basically every device in the system needs to in some sense have similar to our biometric identification. Every device needs to have an identification which is somehow tied to some kind of root of trust of some kind. And I think some of these things in the enterprise level people have already solutions for that. The question is, are they, like you have these TPMs, you have this trust zones, etc.
It's part of your official setup, but now if I can access the video from that device, then I can use that to, and as you said, right, you have it pointed all over the city, and maybe a bank or an ATM is covered, and if you're covering roads, then I can figure out where all the police cars are and stuff. What prevents me from writing a malicious app to do all of that?
The access to the data is, is kind of, you have to get access to the data. So everything, so it's there is an owner of the data. In the case, it could be the city. So if you want to access those streams, you need to have a relationship with the city to get access to the data. Now, if you do some bad things with the data, that could happen. But there is some very clear, shall we say, audit trail as to you have taken that data. It's recorded somewhere.
Yeah, so
And
I provide some bona fide services, but on the sly, I also use the data to do all of these things.
right. Yeah, I guess it's possible. I don't know. I mean, security is like a big topic, and there could be ways of hacking around the systems. But the thing is that at least the point is there is end-to-end encryption with also strong identification of devices and humans, right? So there is an identity management system in place. And the data is only given to authorized people, essentially. The owner of the data authorizes the use of the data. So that is the kind of framework we can put in.
So standards of security and privacy, do you see that those being built into the RFP, or is it left to interpretation?
See, the right now it is at a very high level. For example, they will say use X.509 certificates. That is kind of the level. So that is where the next level of detail as to what it should be in more more precise terms.
In some sense, this is the precise. I mean, like this is an implementation detail, right? What do I care about whether it's using one certificate, another certificate? I want to know what my end-to-end guarantee is, and then I work backwards and figure out what cryptographic protocols are needed.
Right.
But in some sense, these are the low level. These are the wrong details to start with. It seems like. You're right.
the certificates are one way of implementing security. I agree with you. So what we are actually doing is that at a high level you want encrypted communication, right? That is a high level requirement. But how do you achieve that encrypted communication, right? So what we want to actually propose now, essentially what we are doing is, I'll just come to that. There is a consortium we are making where we are coming up with a more detailed specification. Some of it on the security side is kind of on the implementation. Probably it is at a flavor of implementation. Use this, yeah. So that's what it is. Yes. So there's a lot of POC work which we are doing with these some of these devices we are making. This is a concept smart pole which we have made, which has these this is a smart street light which is on this pole, and there is a gateway out here, which has of course a Raspberry Pi on that. Then we have a network of these poles, and this is the just an example application where very toy application where you could use video data, have analytics run off the video data, and then do something to manage your street lights. So where your kind of this heterogeneous things through the same platform allows you to do that stuff. So what we have here is a pole with a camera pointing.
But how much power would be consumed if you had a Raspberry Pi on every street pole and every device?
I don't think the Raspberry Pis consume that much power, because the street lights themselves are about 30 watts to 90 watts. Raspberry Pi will be a few watts, so it's not going to be much. The cameras are also they can consume quite a bit of power compared to because cameras are pretty much a Linux box with optics and so on. So
a real question. There's a Chicago array of things which was trying to deploy this significant set of sensors, very aesthetically packaged around the city. And the concept was that they would put thousands of these, 10,000s of these, and they were funded for that. Now 5 years later, it turns out that there are about 150 nodes. And the deployment cost in Chicago, which is a different situation, is about $3,000 to $5,000 per pole. So what's been the experience doing pole-based power source sensor networks?
I think there's not much experience, frankly speaking. So in fact, this would we'll have to kind of go ahead and see, is it even worth putting these computes in every pole, I think some of that we have to learn as we go forward. So we are not there. Yeah, I agree with you. Yeah. In fact, we have had some discussion with the array of things, people, and so on. And we wanted to use that, but then we realized it's too expensive for us what they have right now. So yeah. So anyway, so this particular, you have probably seen this video, so I'll just move on. All this is saying it's just a people detector which turns on the street light. So it's a very simple thing. We are actually doing this, setting this test bed in Electronic City. They have been kind of very willing to work with us. So there is a fiber loop out here. In this Infosys Avenue, Wipro Avenue, and this other road. And the stars are the junctions where there are some cameras which have been set up. And all this data is going into a micro data center which is set up in their office. So like that, there are two other rings. So there are these 3 rings which have been set up now. And all the data is coming in. And this reference stack which we are developing can be put out there, and we can kind of develop the stack as we go along with actual data coming in from these sources. Of course, they are interested in traffic management, so we want to kind of see if we can help them with that. Hopefully with this kind of activity, we can have a solid stack which is kind of tested out and made available to people.
So what all data is collected here?
Basically, right now, see, in Electronic City, they have this cameras out here. Then they have a solid waste management system, and they want to actually, they're trying hard to set up a smart street light management system. And parking is something which they are concerned with. Parking management is something they want to do.
So does that mean like infrared sensors are there?
Right now, these have, there are no infrared sensors. These are just standard cameras. But we'll put 1 or 2 thermal imagers also as an experiment in this test bed to see what we can do with those. Yeah. This is the network. This is an optical fiber loop which is based on GPON, gigabit passive optical network. Each of the poles in Electronic City has this connectivity to the PON, and then these are there is a LoRa network also to pick up data from some of the sensors are LoRa based sensors. So they are also very interested in water management. So smart water management is another use case for them. So we are also looking at how to create a API interface to the network itself, so that some of the things I mentioned about adaptive QoS and so on can be experimented as part of this. So the application can go and change the network setting. Of course, going forward, these kinds of interfaces in the street become interesting to support autonomous vehicles, so connected autonomous vehicles. So those, where you can have these poles, have beacons and embedded sensors, radars, etc. And this is again where edge compute becomes very interesting for low latency control type things. So these are different applications. It's not video analytics from a privacy or that perspective, bandwidth reduction. It's more from a latency perspective. And again, this is, I think, is an open problem challenge of how do you do this reliable real-time control, especially for mobile things as things are moving around. And this is where this is also in sync with the 5G activity. So this kind of a setup is also, we're planning to use it to create a 5G test bed for that. So I kind of talked about many different things, some of it more researchy and some of it's kind of more mundane. But the thing is that for the city stack, the data stack, the way we are going about it now is we are kind of forming a consortium of academia industry consortium with some companies like Intel, Dell, VMware, Tejas, Bosch, Cisco. These are all interested to be part of this consortium. So now we are working together to develop the more detailed specification of this particular data layer. I've also left others out here, so hopefully there will be interest from Microsoft to also participate in this and other companies as we go forward. And the idea is that that stack which we are seeing, the data layer stack, is articulated out, a reference implementation is created and made available. It should be an open reference implementation, completely open source technology. And hopefully that will, and that gets tested out in Electronic City. So it's a solid stack, and hopefully that can become the kernel for all smart city implementations as we go forward in India. So that is the aspiration. So just to summarize, that data layer is what we are focusing on as part of the smart city solution, because that's the key foundational layer, and it's, it needs to be open with the SDKs, APIs, and so on. And the reference implementation will be open source and made available, and it should be looking at the future, enabling future applications in AI and distributed computing and things like that. And it can't be done by one entity, and it really needs a consortium with, a lot of these problems probably you guys have also figured out. But I think with companies, they hesitate to be, this is where the academia kind of comes in. It can be a neutral entity which can help get this kind of activity going. And this would probably be something unique in India, and this kind of happens routinely in the West, but this would be something interesting if we can do it in India. So, so with that, I would like to thank our really good team we have in the Robert Bosch Center at ISC, and also this members of this India Stack consortium, which is kind of evolving, and I hope that some of you can also participate in that. So thank you for your attention.